Hello everyone, welcome to Brain Blitz Audios. Today in this episode of VITEEE Questions with Solution, we are going to be looking at some previous year questions which were asked in VITEEE. So today in this math video we're going to be looking at the chapter Probability Distribution. This deals with chapters such as probability, permutations and combinations, etc. So there are a lot of questions which are asked in VITEEE in previous years, and today we're going to be looking at some of these questions along with their solutions. Here comes our first question. The number of ways in which 3 prizes can be distributed to 4 children so that no child gets all 3 prizes are A 64, B 62, C 60, D none of these. So, which of these options are correct? Well, we know that each of these 3 prizes can be given to any 4 children. Any of the 4 children. So therefore, total ways of distributing those prizes can be written as 4C1 times 4C1 times 4C1. So that basically means any 4 of the children can be given one prize, any 4 of the children can be given a second prize, and any 4 of the children can be given a third prize. So therefore, 4C1 gives you 4, and then that means total ways will be 4 times 4 times 4. That is equal to 64. Now notice that the number of ways in which one child gets all the 3 prizes. Now that is also for C1. The reason being that here 1 refers to 1 kid being chosen to take all the prizes, and there are 4 kids in here. So 4C1 would be the correct combination. So 4C1 is also equal to 4. So the total number of ways in order to distribute the prizes is 64. The number of ways in which one child gets all 3 prizes is 4. So therefore, the number of ways in which no child gets all 3 prizes, now this is equal to total number of ways minus the number of ways all prizes given to one child. So that means it will be 64 minus 4, which is equal to 60. So therefore, the correct option here is option C, 60. So 60 is the correct answer for this question, which was asked in 2018. What we have to do is use combination in order to find out the total number of ways in which we can distribute 3 prizes, and then how we can distribute the prizes, all the prizes for one child. And then we have to subtract the second value from the first in order to get the required probability, the required number of ways. Now, let's look at another question. If A and B are events such that P of A is 0.42, P of B is 0.48, and P of A and B is 0.16. Then we have 3 statements. We need to find out which of these statements are correct. So P of A and B is the same thing as P of A intersection B. That means the terms belong to both A and B, the elements inside it. So we know that P of A is 0.42. So P of not A, which is P of A bar, can be written as 1 minus P of A. That is 1 minus 0.42. 100 minus 42 gives you 58. So that means 0.58 will be the correct value of P of A bar, which means that statement 1 is correct. Now what about statement 2? P of not B. P P of not B will be the same thing as P of B bar, which is 1 minus P of B. So 1 minus P of B is 1 minus 0.48. So 100 minus 48 gives you 52. So the probability here will be 0.52. So that means the second statement is also correct. Now, P of A or B is the same thing as A union B. So we now know P of A, P of B, and P of A intersection B. It's a good thing that we have all of those values, because then we can calculate P of A union B. So P of A union B is P of A plus P of B minus P of A intersection B. So that is equal to 0.42 plus 0.48 minus 0.16. So 0.42 plus 0.48 gives you 0.9. 42 plus 48, simple addition, that gives you 90. And 0.9 minus 0.16, that's 90 minus 16. 90 minus 10 is 80. 80 minus 6 is 74. So therefore 0.74 is the value of P of A union B. So that means P of A or B being 0.47 is downright incorrect. So we now know that statements 1 and 2 are correct. So therefore, among the given options, you can see that option A is the correct option. It says only 1 and 2 are correct, which is true. In option B, only 2 and 3 are correct is given, which is wrong because 3 is incorrect. The same story for option C, only 1 and 3 are 2 because 3 again is incorrect. And final statement option, the final option D, all 3 statements are correct is not true because P of A union B is not 0.47. So therefore option A, only 1 and 2 are correct, is the correct answer for this question, which was asked in 2018. Now, let's look at another question. A signal, which can be green or red, with probability 4 by 5 and 1 by 5 respectively, is received by station A and then transmitted to station B. The probability of each station receiving the signal correctly is 3 by 4. If the signal received at station B is given, then the probability that the original signal is green is it 3 by 5, 6 by 7, 20 by 23, or 9 by 20? So, how do we solve this question? Well, it's a good idea for this particular question to visualize what is the scenario. So, the scenario is we have a source, let's say S, and from there, you sent out either a green signal or a red signal. If it's a green signal, the probability is 4 by 5. And if you sent a red signal, its probability is 1 by 5. So now you have G for green and R for red. Now, when green was sent out correctly, which happens 3 by 4 of the time, the station A receives the green signal. However, there is a probability of 1 by 4 for the message sent being an error. So therefore, the receiving being in error, so therefore 1 by 4th of the time, station A will get a red signal. And similar story here, when you have 3 by 4, it is A red, and if you have 1 by 4, it's A green. So if you have A green, you have a 3 by 4th chance of receiving the signal green at B, and a 1/4 of a chance of receiving signal red at B. And similarly for AR, the red, 3/4 of the time the signal that B receives is red, but 1 by 4th of the time the signal that B receives is green. So this is the this is the particular scenario in which we are facing. So therefore, there are 3 levels of probability here. The probability that either green or red is received, the probability the green or red is sent, the probability that the station A receives the signal correctly, and then the probability that the station B receives the signal from A correctly. So therefore, as you can see, we have 3 levels of probability here. So therefore, original Bayes theorems and other phenomena, other methods of solving similar questions is not true. Here you have to do the long way, and here's how you do it. So now, if the signal received at station B is given, then the probability that the original signal is green is. So what we're going to do is calculate the probability of a green signal being received at station B. So therefore, that will be the probability of green being sent, A receiving green, and B receiving green. And then there is another probability that green is sent, A gets a red, B gets a green, because there is a double error here. And then P of red signal sent, A gets a green, B gets a green. So A received it incorrectly. And then finally, you have the probability of red being sent, A receiving the signal correctly, but B is receiving the signal incorrectly. So these are the probabilities for the station B receiving a green signal. So now we're going to calculate all of them. So P of G, that means green signal being sent, is 4 by 5, and A receiving a green signal is 3 by 4. B receiving a green signal will also be 3 by 4. Plus, P of G is again 4 by 5, but from here, it is the probability of getting AR is 1 by 4. And then from AR, the probability of getting BG is also 1 by 4. Now, the third case, so red is sent, so 1 by 5. A receives green, so that's an error, so that's 1 by 4. And B receives green, so B receives it correctly, so that means it's 3 by 4. So let's check it out. 1 by 5, and then 1 by 4, and then you have, well, actually 1 by 5, and then you get AG, so that's 1 by 4, and then 3 by 4, that's BG, so that's correct so far. And then finally, you have probability for red, that's 1 by 5, and A receives it correctly, so that's 3 by 4, and B receives it incorrectly, so that's 1 by 4. So 5 times 4 is 20. 20 times 4 gives you a total of 80, so the denominator is 80 because we have the same denominator. So 4 times 3 is 12. 12 times 3 is 36. 4 times 1 times 1 is 4. 1 times 1 times 3 is 3. So therefore, we'll have 36 plus 4 plus 3 plus 3 divided by 80 as P of BG. So therefore, P of BG is equal to 46 divided by 80. Now, we know that the signal that the station B receives is green. We need to find out whether the probability of the signal sent being green. So that means what we essentially need to find out is the probability that green is sent and station B is green. So that is represented as G. So that means P of G, AG, BG, where all are correct, or our second case, which is G, AR, BG, the double error case. So green is sent, and the station B lights up green. So therefore, P of G, that's P of green at both sides, now that's equal to 4 by 5 plus 3 by 4 plus 3 by 4 plus 4 by 5 into 1 by 4 into 1 by 4. So that equals 36 plus 4 divided by 80, which is equal to 40 divided by 80. So therefore, the idea here is to use P of green signal, the original signal being green, given that station B got a green signal. So therefore, that is equal to the probability that we just got, which is 40 by 80 divided by 46 by 80. So therefore, you'll get 40 by 46 as the required probability, which we can simplify to receive 20 by 23. So 20 by 23 is the answer. Therefore, option C is the correct option for this question, which was asked in 2018. Now, the mean and variance of a random variable x having a binomial distribution are 4 and 2 respectively. Then P of x equals 1 is it 1 by 4, 1 by 32, 1 by 16, or 1 by 8? So since we have a binomial distribution, we will use directly the formula of mean as well as variance of a binomial distribution. So in a binomial distribution, the mean is calculated as n times p, which in this case is 4, and the variance is calculated as n times p times 1 minus p, which is npq. In this case, that is 2. So when we divide variance with mean, so variance divided by mean, that is equal to npq divided by np, which is equal to q, and that is equal to 2 by 4. So therefore, the value of q is half, and since q is 1 minus p, the value of p is 1 minus q, which is 1 minus half, that is equal to 1 by 2. So the value of p is 1 by 2, the value of q is 1 by 2. All we need to find out is the value of n, and we know that np equals 4, which means that n times half equals 4. So that means n has to be equal to 4 times 2, which is equal to 8. So now we know the value of n, we know the value of p, we know the value of q. And the reason why we're finding out the values of n, p, and q is because in order to find out the value of p of x equals 1, we would need to use we would need to use a combination. So p of x equals r can be written in combinatorics as ncr, p raised to r, q raised to n minus r. So for x equals 1, it will be 8c1 half raised to 1 and half raised to 8 minus 1. So 8c1 is 8, and 1 by 2, 1 half raised to 1 times half raised to 7 equals half raised to 8. And that's the same thing as 8 times 1 divided by 2 raised to 4 times 2 raised to 4, because 2 raised to 4 times 2 raised to 4 is the same thing as 2 raised to 8. So therefore, you get 8 divided by 16 times 16. And the reason why we did that is to simplify this a bit. So 2 raised to 4, we know the value to be 16. So 8 goes into 16 twice. So therefore, 1 by 2 times 16, which is equal to 1 by 32, is the answer for the probability, the variable distribution of x equals 1. So therefore, 1 by 32 is the correct answer. Therefore, option B is the correct option for this question asked in 2018. So that concludes this episode of VITEEE Questions with Solution. If you want to access more of our useful videos, don't forget to subscribe to our channel, which is Brain Blitz Audios. We have a lot of episodes on VITEEE. If you want to access the playlist, don't forget to click the link, which is present in the description box down below. If you want to get the latest updates about Brain Blitz Audios, then don't forget to hit the bell icon, which is the notifications button present below the video. So until the next webisode, take care, stay safe, bye-bye for now.